Hello and assalamualaikum guys. Uh, Hope you are doing well. Today's our topic is atomic radius and ionization energy. So starting with the first topic, which is atomic radius. Atomic radius. Yes. So it is simply defined as that the more number of shell number of shells, and shells is denoted KLMN. The more numbers of shell directly proportional to is directly proportional to more the more size of to the more size of an atom. So it means that this atomic radius is totally dependent on the shells. For example, if we are having the atom hydrogen, so it is consisting of only one shell, and this one shell is called duplet, and in which it is having one electron and one proton. Okay, one proton. So if there is a atom of hydrogen, here we are having the atom of sodium. Let me draw it. The first shell, second shell, duplet, and it's a nucleus. Okay, so it is having 11 proton. Okay, so 2 electron in the first shell, 8 electron in the L shell, 4, 5, 6, 7, 8. 8 electron here and 1 electron it is here. So it is having the larger atomic the larger atomic size. Okay, so because of that we can call it that hydrogen is having the less atomic size than sodium has. Okay, and if you look at the periodic table, the first group, which is hydrogen, lithium, sodium, and potassium, and going on. So these all the atoms which are having the less atomic radius or atomic size, less atomic size, and the lowest atomic size is having francium, which is also in this group, and which is in the last after cesium. We are having francium, and it is having the lowest energy in the periodic table. Okay, so when we will be moving downward to the group, the atomic size will be decreasing, and down to the group, down to the periodic table group, is known as the atomic size will be decreasing. Okay, atomic size will be decreasing, and if we will be moving at the first group, then it will be more least, as we will compare with the second group. For example, second group is uh, boron, magnesium, and something like, I don't remember, carbon, and something like there it is. Okay, so in this group we will be having the less atomic size than the first group. Why? Because of there are only one electron present in the uh, last shell. But not only this is the reason is this, that let me draw the atom of lithium. Okay, it is having uh, 3 electron. This one is here, last one, and this one is the duplet of lithium, in which it is having 2 electron and it is having 3 proton. The reason is this, that why it is having a less atomic size than magnesium, because there are only 3 proton which are attracting the 3 electron. Okay, so because of that it is having the less atomic size than magnesium. And if we will compare lithium with magnesium, so for example we are having this one on orbit of magnesium. This is the nucleus, this is the duplet, and this is the L shell. So here we are in duplet we are having 2 electron, and this is the nucleus in which we are having uh, a 14 proton. I guess we are having 14 proton in the nucleus of magnesium, 14 proton, and the last shell is having only 1 electron. So if we will compare that this uh, atom with the atom of lithium, so why this magnesium is having the uh, high atomic size? The reason is a less atomic size than lithium, because not lithium, let me draw another. It is having a lowest sign. Let me draw the nucleus, and then first shell, and then second shell of sodium. Okay, this one is the nucleus having uh, 11 proton, 11 proton, 2 electrons are here, 8 are here, 1 2 3 4 5 6 7 8, and the last one shell is having only 1 electron. Okay, it is having only 1 electron. Okay, so this one is the atom of sodium, and this one is the atom of magnesium. So why magnesium is having a low atomic size than sodium has? The reason is this, that here we are having 14 proton which are attracting 14 electron. Okay, and here we are having 11 proton. So because of that, the less number of proton is the means proton number of proton number of proton is inversely proportional to atomic size. Hope you are understanding. Means the more number of proton will be the means the less number of atomic size. For example, if we are magnesium is having 14 proton which are attracting 14 electrons, and at the other side we are having sodium which is having 11 proton, and they are attracting 11 electron. It doesn't matter how much they attract electron. What does the matter is the number of proton. The more number of proton will be having the less number of the less atomic size, and if we are having the less number of proton, then we will be having more atomic size. So let me means tell you the concept and who told about this. So the first man was D. Broglie, who just give an idea about electron, that it is having a both nature, that is, all the smallest particle are having both nature, um, no matter it is electron or meson or the other subatomic particle like proton, neutron, are having two types of nature. They may be, no, they are wave nature, not maybe, they should be wave nature, and they should be a particle. They are having these two characteristics, means it's a dual nature particle. It was said by de Broglie dual nature particle, and it is having a particle nature as well as the wave nature. So it was a problem that we were unable to calculate the means atomic size of an atom, because if you know that wave used to make crust and rough. Okay, so if electron is having a wave nature, so we cannot define the means radius from the orbit towards the nucleus, because radius is equals to the means diameter, half of diameter, or you may say radius is equals to the distance between the center of circle towards the means line, and towards the line of circle or circumference of circle is called radius. Okay, so here we were unable to find radius because at one side we are having this one rough, and in the other side we are having crust. So here we are having more distance as compared to here, so it is changing at every point. So we were unable to find, but we were finding, and we saw a means conclusion, which was that when an atom makes bond when an atom makes bond, then the means then the waves of an electron waves of an electron converted into standing waves. What are standing waves? We will be seeing. Okay, into standing waves. Into standing waves. So what are standing waves? Standing waves are like means they are means simple. They are not having crush or trough. They are simple means like this. These are called standing waves. They used to be stand at one point, don't like crust and trough, and these waves are called standing waves. But note the point here, when an atom makes bond, then we will be saying that the electron is forming a wave nature of standing waves. Okay, so means for example this is the atom of hydrogen, and it is having an electron, and we are having the atom of, you may say, yes, a hydrogen as well. Okay, so first of all, going with the easy concept, we calculated. First of all, we were not having idea, and then we calculated on the basis of molecule, means when atom makes bond, then it is easy to calculate the means atomic size, and it is only easy when there is a homo molecule means same molecule, means if there is a hydrogen, so there is also a hydrogen, so it is easy to calculate it. So how we calculated? So we were having required x diffraction diffraction which helps us to visible the means orbit, or you may say to visible the size of an atom. So here when this they make bond, so the half of the bond distance was equals to the means half of the bond half of the bond distance is equals to the atomic size of an atom. Half of the bond distance was equals to the atomic size of atomic size of an atom. Okay, so this is for only homo molecule. If we are having like HCl, or you may include NaCl, so here we are having different means, you may say number of electrons. So in the last shell of chlorine we are having 7 electron, 3, 4, 5, 6, and the last one is 7. And in the last shell of sodium we are having only 1 electron. Okay, so when they will make bond, so it will means attract this electron. So the half size of this bond distance will be equals to the uh, it will not be means applicable in this rule, because there are hetero molecules available. Hetero means there are different molecules available, so because of that we cannot define the means atomic size by just going with the hetero molecule. We should need to first draw the means Cl2 structure, which is this, that Cl2 when it makes bond with each other like 1 2 3 4 5 6 7, and here we are having another Cl 1 2 3 4 5 6 7. Okay, so when they make bond, so the half of the side, the size for example is there is a half size is 3.6 angstrom, 3.6 angstrom. So we will be subtracting this 3.6 angstrom with the total value which we will be getting from X diffraction. So we can easily find the atomic size of NaCl. Okay, hope you have understanding the concept of atomic size. Now go for ionization energy. I know that this is a very good lecture, and means in a quantity wise it is a means it is having a lot of quantity, so you have to means be there. Okay, so ionization energy, so it can be defined as that the energy which is required to an electron to an atom, sorry, to an atom to remove the electron, to remove the electron from the outermost shell is called, from the outermost shell is called the electron from the outer shell is called ionization potential. Ionization potential. Okay, so this is the definition of you may say ionization potential, or you may say ionization energy. So what is actually this? So we will be defining it like this, that as we are having the atom of helium at the here, and we are having the atom of sodium here. Okay, so helium is having two number of electrons, one is here and the other one is here, and its duplet is completed, and the first shell contains 2 electron, which is a K shell. It contains 2 electron according to 2 and square rule. Okay, like this, 2 1 square equals to 2. Okay, so it contains 2 electrons, so that's why we can say that helium is stable now. Okay, and we in compared to the helium we are having the last shell of sodium, it is having 1 electron. Okay, so means if we are comparing these both things, let me draw the full structure of sodium. Okay, it's the nucleus, it's the first shell, it's a duplet. Okay, that's the second shell, and that's the third shell. It is having 1 electron, it is having 8 electrons, 4 5 6 7 8. So it is having 8 electron, it is having 2 electron. So means if we want to remove the electron from sodium, then it will be very easy to remove the electron from the sodium as compared to the helium, because the reason is this, that helium is helium's electrons are near to nucleus, and if they are near to nucleus, so means positive charge is attracting those electron. So because of that, in case of helium, in case of helium, positive charge are attracting positive charge are attracting electrons. So because of that, there means a lot of energy required to remove the electrons from the helium. So it is that's why helium is having high ionization potential or high ionization energy. Okay, energy as compared to the sodium. So let me give you a last example and then our class will be done. uh, for example, we are having the means atom of chlorine. It's a nucleus, it's a first cell. It will be having two electron, and the uh, L shell will be having 8, and the last one shell will be having 7 electron. Okay, so it is having 2 here and 8 here, 3, no wait, 2, 8, 10, yes, 8 here. So means after this 1, 2, 3, 4, 5, 6, 7, 8 electron are here, and the last one shell is having 7 electron. It is having a need of only 1 electron to complete its outer shell. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so it is having a required means 1 electron, and here we are having the atom of hydrogen. It is having a nucleus and 1 electron. Okay, so if we will be comparing these both means atom, so means the simple thing is that it is having the means the more number of electron in the valence shell, so it will not be leaving its electron. And the means other reason is this, that chlorine is having 17 proton. Okay, which are attracting towards which are attracting electron to not go from there. Okay, so uh, chlorine is having the less ionization potential, because it is having the more number of electron in the valence shell, and it is totally means uh, dependent on the size of the atom, because 17 proton, if there are 17 protons, so means there is a less size, because more number of proton is equals to the less size. So it is having the less size as compared to the means another like sodium, magnesium, so they are having the more size. So it is having the less size, so because of that it is having the less ionization energy. Okay, so you may say atomic size is directly proportional to the ionization energy, and ionization energy is the means energy required to remove electron from the outer shell. Okay, ionization energy. So if we are having hydrogen, so hydrogen can remove its electron very easily and very fastly, as we are comparing with chlorine. So hope you guys enjoyed our lecture. It went very well, and I hope you have understood all the concept of atomic radius or atomic size and ionization energy. So you can take a screenshot from here. It is total legal, and we'll see you in the next video.